Greetings to one and all. Now we are going to know about the inert flare effect. For many heavier B block element, in addition to their group oxygen state, additional group oxygen state also exists, which is equal to G minus 2. For example, germanium, tin and lead have plus 2 and plus 4 oxygen state. Group oxygen state is obtained when all the NS and NP orbital electrons are lost in B block element. Lower oxygen state of plus 2 is obtained due to the loss of NP orbital electrons. NS orbitals are completely filled and it exhibit the extra stability to the atoms. For example, in plus 4 oxygen state, all the 4 electrons are singly occupied. When plus 2 oxygen state, the 2 electrons occupy s orbital, b orbitals looks empty. The completely filled s orbital have somewhat stability. So it contains plus 2 oxidation state also. The relative stability of different oxygen state. S block elements of group 1A form unipositive ions, while that of second A group form M2 plus ions. Plus 1 elements, for example, lithium form plus 1 oxygen state and beryllium form plus 2 oxygen state. The light elements are B block elements, so positive and negative oxygen state, while some of the heavy elements B block elements show the 2 positive oxygen state. For example, carbon form plus 4 and minus 4, and the silicon also form plus 4 and minus 4 oxygen state. Nitrogen, phosphorus, sulfur, chlorine form plus oxygen state and also the minus oxygen state. Heavy elements gallium form plus 1 and plus 3 oxygen state. Indium, germanium, tin, osmium and all are form plus 4 plus oxygen state. The diagonalship and anomalous behavior of first members of each group. As we move from diagonally in periodic table, the elements belonging to different groups show the certain similarity because of it the ionic charge increases. For example, lithium have diagonal relationship with magnesium, beryllium will show the diagonal relationship with aluminum, and boron will show the diagonal relationship with silica. The non-metals show diagonalism due to the similarity in their electronegativities. For example, carbon and phosphorus have nearly same electronegativity value. Nitrogen and sulfur also have the same, and oxygen and chlorine also have the nearly same electronegativity values. Now we are going to know about the diagonal relationship of lithium and magnesium. The atomic radius of lithium is 1.34 while that of magnesium is 1.364. The radii of Li plus ions is 0.6 angstrom and that of Mg2 plus ions is 0.6 angstrom. The polarizing power of Li plus and Mg2 plus ions are same. Lithium and magnesium are soluble in water. They have the electronegativity values are same. They decompose in water by liberation of hydrogen. They hardly react with bromine. The lithium and magnesium hydroxides are weaker base. Lithium and magnesium chlorides are deliquescent. Lithium and magnesium form the monooxides such as Li2O and MgO. The diagonal relationship between beryllium and aluminum. Beryllium and aluminum form the covalent bond. The oxidation state potentials are nearly same. They enter positive to the con nitric acid. They form many complexes. Beryllium and aluminum are amphoteric in nature. They react both with acid and alkali and form these salts. Beryllium and aluminum react with sodium hydroxide by the liberation of hydrogen. The diagonal relationship of boron and silicon. Both have non-metallic in character. Boron and silicon have high densities and boiling point. Both occur in combined state. Boron and silicon form covalent compound. Boron and silicon are have high ionization energy. Boron oxides such as B2O3 and SiO2 are weakly acidic. They are bad conductors of electricity. B2O3 and SiO2 are weakly acidic. They dissolve in strong alkali and form the metaborates. Orthoporic acid and orthosilicic acid react with alcohols and sulfuric acid and form the esters. This green edged flame it is used for the quantitative analysis of borate. The diagonal relationship of carbon and phosphorus. Both carbon and phosphorus exhibit allotropes. Both carbon and phosphorus show almost same electronegativity. Both form strong bi and sigma bond. Like carbon and phosphorus also form triple bonds. The resemblance of nitrogen and sulfur. Sulfur exists as a solid, while that of nitrogen exists as a gas. Both elements exhibit diamagnetism. The atomic number of nitrogen and sulfur are 7 and 16. The number of electrons in the outermost cell is 3 for nitrogen and that of 6 for sulfur. They belong to different families. Sulfur belong to the oxygen family and nitrogen is a member of nitrogen family. The direct relationship between the oxygen and fluorine. Oxygen size of the oxygen is more and it is less covalent, while that of fluorine is its size is less and it is the more covalent in nature. The electronegativity of oxygen is less and that of fluorine is more. Thank you one and all for your patience. A happy self learning. Thank you.